I've been talking in class, haven't given you the address yet or the name of a Microsoft Word alternative. For this class, you need Word in your virtual machine. Be nice, though you could do your homework, my worksheets inside your virtual machine here on the Mac. There is an option, and I think I might even send you the email to everybody if I can find them where to go. Come on, scroll. That was close. The software that I recommend is Kingsoft Free Suite. The reason I recommend it is because it treats my worksheets very, very well. So after class, after this lecture, next time, in your spare time when the room's open, you could come in here, log into your machine, open up your virtual machine. I will forward this email to you. And then you could install this King Office Suite free. Takes you to this website, you download it into your virtual machine. And it will give you a spreadsheet, and it will give you a word processor that all work pretty well with the Microsoft Office products. This is the one I feel works best with the documents that I need you to work with. If it fails and it aggravates you, then don't use it and use Microsoft Word in one of the other labs. You don't have to do my homework in here. It's just a Word document. So Kingsoft, and let me forward that email to everybody. Please. So that email and that link will be in there. Somebody was just asking me, Eric, was it you? I don't remember, about LibreOffice. That's another alternative, and that works pretty good. But the one I really liked best when I compared the two was Kingsoft. And so now here's your chance to play with it in a virtual machine. You don't have to install it at home. Play with it here. If you like it here, then install it at home. It should be 100% free. I'm also in my virtual machine here, so now that I'm in Windows, I can click on the Office. You can't do this if you're running Firefox in the Mac because it doesn't seem to work. I can click Office 365, and there's the software. And I hope it's still thinking, because usually there they are. There's icons that say, here's all the software that's available to you for free, 5 licenses. If you wish, you can install this in your virtual machine and use one of your licenses in the virtual machine. It's not technically legal, but then you could make a copy of your virtual machine and take it to a different place and use Microsoft Office in your virtual machine in a different place. You have to have VMware to do that, but that's technically not legal. I said it, I told you, but how are they going to know? I'm not sure if they can or not. What I couldn't do was install it in your startup virtual machines and have all of you using it. That wouldn't work. So that's how you get to Microsoft Office at home, and if you wish to install it in your virtual machine, you may, and it'll work. If you did that, I would suggest you, as soon as it's done, take a snapshot. So if something goes wrong and your virtual machine goes haywire, you can revert back to the day after you, or the moment after you installed Microsoft Office, and fix it again. Pam's getting tired. I'm throwing a lot of technical stuff at you. No, I'm going to show you that one. I'm going to my website. If you wish to follow along in my notes, that's not a bad idea. Go to my website, click on Programming Logic, Programming Concepts, Notes. This is being recorded, so if you fall asleep, you can always go get it later. I'm going to start with my programming philosophy. Remember, I'm assuming you know nothing. This is the risk of recording. My microphone's over there. I like to walk every now and then. My voice gets soft, just turn the volume up. And then turn it back down again when I go back, but that's the problem. My philosophy is I can teach you how to program. There's rules. It's like teaching you to spell. There's rules. And once you learn the rules of programming are called syntax. I think that's going to show up a little bit later. Don't take notes. Just not worth it. It's all a bunch of theory, Volcker's philosophies. Not on any test, I promise you. Okay, so pay attention. I can teach you the programming part. I can teach you to spell. What is harder to do is teach you logic. Notice the name of the class, Programming Logic and Programming Logic Intermediate. Teaching you to program, that's not too bad. Visual Studio, the program we're going to use, actually helps you learn some of the rules. But then there's logic involved. To create programs that work the way you want them to, you have to apply logic to them. That's harder. It's like teaching somebody to construct sentences the right way. That's harder than teaching them to spell. I taught my 15-year-old to drive. That wasn't bad. You hold the wheel, you do this to go left, you do that to go right. But then let them out on the street, and there's logic involved. And it's much harder. You learn that better through experience. That's why there's so many programs on that assignments list. That's the experience. By the way, none of those programs are huge till the very end. And even then, they're not huge, they're just bigger. The huge ones come next year. We build them in pieces. Nobody builds programs, sits down and writes 50,000 lines of code in a week or two. You write a bit here and you make that work. You write another bit there and you make that work. Tie the two together, make sure they communicate with each other, and then add another piece and another piece. I will be bragging about my Wisconsin Lions Camp program that I've written. Wisconsin Lions Camp's out in Rochhold. They hold a summer camp every summer for disabled kids to have fun. It's a great place. One of their administrators took my class once and she said, would you be willing to help us? We need a program to manage the medications. These disabled kids, some of them come on with carry-on suitcases of medication for a week. It's crazy. And the nursing staff there has to manage all of that, and doing it on paper was a nightmare. This was 1998, 99. I said, sure, I'll give it a shot. And they've been using it ever since. But that program just keeps growing and growing and growing. And when I show it to people, say, my God, you wrote all that? Not at once, over 10 years. Not quite, but over 10 years. Because they call me and they say, can you make it do this? And I go, sure, give me a week, whatever. And I make it do it. And all of a sudden, it does something more and more and more. This is the first summer they have not called me and said, can you come? Something's wrong. It was so cool. My program works and they don't need me. I wrote another program for St. Mike's. They haven't called me in 5 years. I don't even know if they're, I hope they're still using it. I think they are. So the programming I can teach you, the logic, that's a little tougher. That's why you're writing programs. That's the part that most of you are going to struggle with. The rules of the language, the syntax really isn't that difficult. You can look it up. But the logic you can't look up. You got to apply it. You got to practice. Basic problem solving steps. You got to understand the problem. Networkers and software developers both next semester are going to take a course called Systems Analysis. It's all about identifying and understanding a problem. You don't do any programming. You don't build any networks. You don't take any computers apart. You learn how to understand, document problems, how to communicate with the people who want to build the programs. My current project's for Boys and Girls Club. I spent 2 weeks, felt like, talking to the woman about how this program's going to work and how they function. Understanding the problem before I did anything. Then, so you get a whole class here. If you're a software developer, 2 classes, systems analysis and then systems design. That's how important this stuff is. Then when you think you got your head around the problem, then you start thinking about alternative ways to solve the problem. It may not be a computer program. Software developers, the problem is you need a computer program. That's the answer to every problem. I can't take roll. I need a computer program to take attendance. Really what it is, if you get really into software development, is you need something to write that's fun. That's an attendance program for me. That's useful for me. But it's not always a computer program. Maybe they just need to fix their filing system, their paper filing system. But in today's world, you need an app for that. We're writing apps right now, but we're using Visual Studio. We're not writing Android apps, we're writing Windows. An app is just a program, it's no different. They're just sometimes smaller, but not anymore. Those apps you run on an iPad and Android apps, those things are huge. Very, very complex. So you'll see me use the word app a lot more than program. Change the name of the course. App Development Beginning with logic. But for us in this class, it's a programming class. The answer is always, you can't come up with a better way. You're going to write a program. Then you got to write the program. We got to list the instructions, holy cow, that enable you to solve the problem using a solution. Here's the kicker. The computer's only going to do what you, the software developer, the programmer, are going to tell it to do. If Windows doesn't work, it's because the Windows programmers didn't give it the right set of instructions for the things that you did. When you stand on your right foot, raise your left hand, and double click with the mouse in the wrong place, it just crashes. They forgot to handle that. Okay, the left leg, right arm, whatever I did, that doesn't matter. But you could click in just the right way to do something that Microsoft didn't allow for. And if you tried to do it again, you probably couldn't. So when Windows crashes, what do? You reboot it, it thumbs up, and everything's fine, and it never crashes again until the next time you do something wrong. When's the last time Windows crashed on you? That used to be a big complaint, right? Windows crashing all the time, blue screen of death. When's the last time that happened to you? Doesn't happen to me hardly at all anymore. They're getting better over there. No, Windows has been around a long time, and they just keep tweaking it and making it better. Computers today seem to do things automatically, like send you a bling when an email comes in. That's not automatic. Somebody programmed it. An email came in and sensed that. Bling. Nothing happens automatically. Feels like it sometimes. Programming is easier than it used to be because we've combined things, and you say this command, and what used to take 100 lines of code now takes one. And I'll mention that to you a lot in this class. I used to do it this way, and there's 6, 7 lines of code, and then I found this. One line of code does exactly the same thing, probably faster. Programming has evolved. I started programming in 1975. It's come a long way since then. Even then, it had already evolved because the first programs were in the 50s. We've been at this for 60 years. It should evolve, right? It should be easier and better. There's still some things we can't get around. And here's the real kicker. Once you think your program works, test it. In this class, use the evaluation sheet. That's not good enough. Run the program. Does it always work, or can you crash it? In this class, you can crash your programs because making your programs idiot-proof is difficult. You have to teach it what an idiot looks like. How many different kinds of those are there? You have to teach it. You're not going to learn much in this class about how to do that. Software developers, you'll do that, and networkers too, if you wish. When I say software developers, networkers, I'm just assuming you don't want any more of this, and that's not true. Many of you, this is all right, maybe I want some more. You can take networking or programming logic intermediate. It'll fit in your schedule. If you want to get both degrees, you can finish one whole year of both degrees before you have to make up your mind. Catherine told me today that she tells you in the networking class, about October, you'll figure it out, whichever one you like best. Maybe. But when I say software developers, that doesn't mean you networkers can't take it if you're interested. You want to learn web programming? You can take it. Database development? Catherine would love you if you take that. So would your boss take database development. It's just not part of your program. So if I say that, I'm not trying to push you away and say, no, you can't take those classes. That's not the case at all. It's just, you normally don't. But you can. So you need to evaluate and test that program, make sure it works. But Windows still isn't perfect, right? It still locks up sometimes, does stupid things every now and then. How come? Because somebody did something that nobody ever tested. And the program doesn't know how to handle it, so it does the best it can, and that's not what you meant. Stupid Windows. Stupid Windows. Just take a look. You'll understand it's a whole lot better when you start writing 20 lines of code and it doesn't do what you want it to do. Where Windows, I think last time I looked, was 100 million lines of code, commands that have to be just right. If I ask you, how do you get from here to belt? So many different ways can you do it? Lots of different ways, right? And if it was my wife telling you, and I was giving you instructions, said that's the long way. It doesn't matter which one I pick. It's the long way to get to belts. That's my wife joke. It's always in the recordings. She goes looking for them, I think. But anyways. But you still have, these computers, I think it's going to say it just a little bit later, they're stupid. You got to tell them exactly right. First thing you got to figure out, if you're leaving here and you try to give somebody instructions, where are you parked? Are you over here on the north side of the building? Are you across the street? By the way, you can do that. Across from Chase Bank, across the street, there's a parking lot that's free. Are you in the parking lot on across Highway 66? That one's also free. You can park there forever. Not 2 hours like the south side here. Where are you parked? I got to know that first, because then the instructions change, right? Oh, man. Imagine how hard it is to get somebody to belts if they can barely know how to drive. And then imagine how hard it is to write the instructions so that if you're at the Mid-State campus, I don't care where you're parked, I'll get you to belts. Then you hit the train. Don't go by the train. I know, okay. So we're going to find, and in our class, that requirement for the program comes from my assignment. Those have been beat up by your predecessors, all the students in my programming logic class for years. Many of these programs I've been using for years. They're good examples. They're good practice exercises for you to gain that logic experience. And so if a student doesn't quite understand my requirements, then I try to figure out, do I need to tweak them or is it a student problem? And I've tweaked it many times. So they should be fairly clear. In the real world, that's a little harder to do. And then the writing to handle all circumstances. Where are you parked? Handle all of those. Could be tough. Harder, right? Could be hard. Then we break the program into small parts. First, let's get you out of the parking lot. That's a challenge in itself. Once you're out of the parking lot, or we get everybody to the, wouldn't that be great? Doesn't matter where you're parked, I'm going to get you all to the same exit of our parking lot. If you're all there, then I can write another piece of program to get you to Belts, or to get you to Division Street. Right? And that one should be pretty much the same. And then once you're in Division Street, then we can write a program to get to Belts. And then once you hit Belts, then we can write a program to figure out whether you park underneath the sign or you go across the street. Or you drive by because the line's too long. But we can break programs into parts. That's what happened with the Lions Camp for me. Broke it into parts. What do you need it to do most? I wrote that part. Took months. Got it to work. Now what? Can you make it do this? Yep. Tap that in. More months. Can you make it do this? Well, that's a piece of cake. A couple lines of code. There you go. Oh, you're a genius. Hardly. It just keeps building and building and building. I'm going to show you how to do that. You can do it right now. You can write 3 lines of code and test it. These 3 lines should do this. Did they? No. Let's fix that till it does. Okay, that works. Now next, logically, I think I got to do this, this, and this. And then you test it again. Does it work? No. These 3 worked. Must be these 3 lines of code. Narrows it down. I'm going to show you how to do all that stuff. It's just a theory right now. Programs are written in small parts. There are 3 basic control structures. It's going to take me 17 weeks to teach you how to do 3 things. Not exactly. Any Lego experts in here? Like to play with Legos? I got granddaughters, and before them, I played with Legos all the time. There's all these different kinds of Legos, but let's go back in time to when Legos first came out, and there were 2, 3, 4 basic shapes. 4 dots, 2 dots, 6 dots maybe. There wasn't the little flounder fish. Granddaughter loves it. This big, loses it all. But anyways, 3 blocks. What can you build with 3 basic shapes? If you got enough of them, anything, right? So I made the coolest houses with 3 basic shapes. Cars, even better when wheels came along. Airplanes, helicopters, all these cool chickens, you name it, I can do it. 3 basic shapes. Same thing in programming. three basic tools. You put them together in different ways using logic, just like Legos. Put them together in different ways to solve different programming problems. The first one is called sequential processing. Once you get out of the parking lot, you turn left. You go straight for a mile. If there's a stoplight, you stop if you need to. Otherwise, you go. Then you go straight for another half a mile, and then you stop and turn right. Sequential. Do this, and then this, and then this. But I also threw in there a decision, didn't I? I got jumped ahead there. I threw in a decision. Said, if there's a stoplight, stop. If you're male, go this way. If you're female, go that way in the program. A couple of examples here. But this is just step, step, step. First step, next step, next step. We just did that, right? Create a personal account on a Mac. Step, 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 step. There was no decisions. You all did the same thing I did. Create a virtual machine. Step, 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 step. Virtual machine. Often, though, there's decisions involved. Sequence structure number 2. Decisions involved. I need to make a decision. Computer programmers know how to make decisions. You'll teach them to ask questions. What's the state of the world? Is it raining out? Is it sunny? Did the user enter their name or not? You ask all kinds of questions. And if the answer is yes, you do one thing, the program does one thing. If the answer is no, it does another thing, a different thing. And it takes different paths based on the circumstances. Here's an example, sequential processing. Get the person's annual salary. I shouldn't point to the screen, doesn't work very good in the recording. Get the person's annual salary. After that, sequential processing, find out how many years they've been working here. After that, ask a question. Notice I can't put the question first because until I have the years of service, I can't ask if it's more than one. The sequence is important. Just like turning right out of the parking lot, there's another right turn later. I can't do that right away. That's not going to work. Same thing. That's the logic. That's the hard part. And then we ask a question. If they've been here more than a year, then give them a raise and show it to them. If they haven't been here more than a year, then we do this instead. We don't do both. We tell them it's time for a review. They don't automatically get a raise. They get a review. That's just an example of a decision. So that's 2 kinds of processes, 2 kinds of Legos. The third is repetition. Do it again. Computers are great, especially for parents. My granddaughter, I have a storybook that's on my iPad, and she just loves that storybook. She gets to the end, what does she want to do now? Do it again. What do I want to do? Something else, please. That computer will do it again and again and again to her heart's content. Computers can do a million things fast. The same thing, slightly different, fast. Repeat the same set of steps over and over and over again. So here's the example that incorporates the one above. Get the annual salary, get the years of service, if it's more than one, otherwise do this, and then do it again for the next employee. And keep going until you run out of employees. This is called pseudocode. It's not really code, but it's kind of close. Those of you with some programming experience, repeat, if, get. They're all programming commands, but there's no rules here. I'm just kind of winging it. Notice the indentation to show ownership. Here's the beginning of my loop. Here's the end of my loop. Here's what you do when it's true. Here's what you do when it's false. You'll learn how to do all that because it makes this easier to read. If I just strung that out in one big old long line, some programming languages say, that's fine, I can figure that. Programming languages can figure that out. Computers can figure it out. But we humans who have to take care of this stuff when it breaks, we like it indented, looking nice. And remember, I didn't tell you guys. I have a reputation. I am anal. You have to be, right? As a programmer, I keep pointing to Paul. Paul's the new guy back there. He came from Sentry because he doesn't have any C# experience. He wants some. He's bored to tears because he knows all this stuff. He's been a programmer. This is the basics. He's got to suffer through it, though, because the rest of you don't. That's okay. But if I tell lies, you straighten me out, okay?
I'll throw in amens.
Oh, that even better. Thank you. But if this is off by one character, I'm not happy. Why is it supposed to be out here? It's supposed to be, they got to be lined up just right. The good news is Visual Studio helps you with that. and we're going to learn it all. Just like everything else you've been learning the last couple of days, this is an overview. Hang in there. If it's a lot coming at you, this is not the day to ask me for a tutor. It's none of this even on test. It's just theory right now. And I will refer back to this quite a bit. Remember when I said this in Unit 2, and you're going, but I'll solidify it. Thinking like a programmer. When you get this pink concept down, you're thinking like a programmer. Computers are stupid. I used to put is in there because it sounds even better. Computers is stupid.
It does.
But unfortunately, I also harp on you spelling things and grammatically right, so putting it in my notes wasn't a good idea. But computers are stupid. They only do what you tell them to. They only do what the programmer tells them to. Well, wait a minute. What is the best, who's the chess champion in the world right now? It's a computer. Beats every chess master in the world. How does that jive with computers? It's stupid.
It only knows how to play chess.
That's true. That's a good point. It only knows how to play chess. Stupid computer. Okay, let's play checkers. Tic-tac-toe. Chess, let's go. But how can you beat a grandmaster if you're stupid? It's not. It's a programmer. Go ahead.
Oh, it calculates the moves and possibilities.
How does it do that? A programmer taught it how. A programmer had to sit down and say, knights move like this, and bishops move like that, and queens can do this, and pawns can do that. And if two pieces share the same cell, that means one of them blows up in Harry Potter, and all those things. All that stuff has to be trained. You have to be trained to do that. Okay, well, that's just the rules of chess. That's actually, it's not, I'm going to say that's the easy part. And that's not, I have never programmed a chess game. There's just too many rules for me to want to worry about. But somebody did it, or probably somebody's did it. Lots of people did it. But how can it seem so smart? They create the illusion of intelligence using speed and the ability to store immense amounts of data. I left my flash drive at home. 16 gigabytes of data. I heard on the radio the other day that the first version of Mario Brothers was 40,000 bytes. That's 80 times smaller than one picture you take with your digital camera right now. The amount of space it takes. We're progressing, I guess. But we have immense amounts of data. A gigabyte is 1,000 characters of storage. I used to tell people that a megabyte, that's a million, is the equivalent of a 400-page novel. Every character, space, comma, whatever, in a 400-page novel. It's a million. Now we're talking gigabytes and their throwaways. Who cares? It's a gigabyte, no big deal. That's 1,000 400-page novels. That's 1 gigabyte. Your flash drive, I'm going, $8 to get 16 gigabytes. That's 16,000 novels you could put on there. Or 4 or 5 pictures, whatever. You know, but the storage it's immense, and it's cheap, and it's getting cheaper. I've suggested maybe a terabyte. That's what comes after giga. That's a trillion, 1,000 billion. It's 1,400,000-page novels on one little device. If you think about it, you start losing sleep. Don't think about this stuff. And that's just a terabyte, and we can buy it for $50 now. So what are they using for Big Blue, the computer who won the chess championship? Immense amounts. What's next? Anybody know? Maybe it's petabytes.
It is.
Thank you. That's not common yet, but terabytes was unimaginable. Now we get it for $50. Petabytes are used in big storage farms and those kind of things. They're not uncommon, but for us home users, they're not run-of-the-mill just yet. Maybe before some of you graduate, you'll be thinking about upgrading your flash drives to petabytes. I doubt it. But these are huge. So immense amounts of data. What that Big Blue computer does is it remembers every situation it's ever seen on a chessboard. Supposedly gazillions of them possible, but it remembers every single one it's ever seen. Can you do that? No. You have more storage. How come you can't do that? Oh. You probably could.
And more important stuff to remember
Yeah, it downloads some of the things right off my ear. But anyway, it remembers, it's been programmed to, okay, here's the chessboard. What did the white piece do? It moved here. Remember that. And then it also remembers its response and whether it won or lost. So white moves here, the computer moves here, and it says, okay, and then it says, it waits till the end of the game and says, when I did that, I lost. Well, I'm not doing that again. Or maybe I will and do it 5 or 6 times, and if I always lose, it can do all that kind of stuff. And then it's halfway in the game and half the pieces are gone, and it remembers all that stuff. And it's also very fast. In my chart a couple days ago, I said when you buy a computer for this class, it should do 2 to 3 gigahertz. Giga is billion, right? Hertz is 1 electric cycle. Most computers today, for every cycle, they can do 1 instruction. Wait a minute. 2 to 3 gigahertz per second. They can do 2 to 3 billion things per second. Well, that's a rough estimate. It might be 1.5 billion things per second. Then you could have today a quad-core processor. That's 4 computers, and they can share the workload and each do 4 billion things per second. Oh my God. And then there's Big Blue. It's a supercomputer. It's got lots and lots and lots of computers that all talk to each other and share information and say, you do this, I got to take care of that. And I can just, so it's not intelligent. It just seems like it because it's extremely fast and it's got a lot of data. I can just imagine poor chess master sitting down and he goes, beep, and the computer goes, beep. Didn't hear it before. I like this. Beep. Chess master does that thing the chess masters do, right? They got the clock. Think about it for 15 minutes and go, beep. Psychologically, it's got to wipe that chess master out after about 20 minutes of this. I'm thinking really hard, and the computer goes, beep. And then it wins all the time. Those guys have got to quit, I'm sure. Right? Because the speed is something we can't quite duplicate yet. I think we have the capacity, we just don't know how to use all that capacity. So computers are just fast. I go to the attendance program and I say, give me the attendance program. Blip, it figures out that it's Monday or Wednesday and it's 4 o'clock, so you must want the roster for programming logic, and here's the list in a blink of an eye. If I gave you a list of papers, say, give me the people in the class that I'm in right now, you know, what time is it? Okay, and you're already way behind. They're not intelligent. They're just fast and they've got vast amounts of storage. And getting faster and smaller and more storage. Cell phone today, you know, there's another example of how many lines of code, what kind of computer it took to put us on the moon. Less than it did for Mario Brothers. And they made it there and back. And today we don't let anything go unless it's got hundreds of thousands of lines of code in it. I think we're getting stupider as we go. Not sure. So computers are stupid. They only pretend to be fast or seem to be intelligent because they're fast. If your program doesn't work, the computer's stupid. It's only doing what you told it to do. So you can cuss and swear and go ahead, because I do it all the time. Stupid program, stupid computer, not doing what I, oh shoot, why didn't I see that? You never slap yourself in the face. Give yourself credit right away when it works. That's cool. Do it, that's fine. But there's only one person to point the finger at, and that's the program. It doesn't do what you want it to do. Something you didn't do right. Because the computer followed your instructions exactly. It can't help but follow your instructions exactly. It can't do anything but do that. It can't. It's not possible for it to do something yet. For it to do something all on its own that nobody ever taught it how to do. Working on it, artificial intelligence. That's not real, it's just fake intelligence. It's still artificial. Artificial intelligence, when it works, is it thinks, put it in a new situation it's never seen in before, and it analyzes it and goes in. Not yet. Time's coming. All right, to be an effective programmer, you have to learn to think like a programmer. Break processes down into steps. If I want instructions to belts, let me get you out of the driveway first, and then I'll get you down Highway 10, and then I'll turn you right. I'm breaking it down into processes. And you have to break this down to extreme levels for computers because they're stupid. I told you to multiply by 0 and you didn't like it. What's wrong with you? That just means 0. No, not always. Not with stupid computers. We have to combine those 3 control structures. Unit 4, sequential processing, a whole unit. Can you tell the computer step by step in the right order what to do? Unit 5, decision processing. Now throw some questions in there and do this is one thing. Unit 6, repetition. When you're done with 6, that's all there is. Okay, maybe there's memory management and a few other things for me to teach you in the next 3 semesters. But you will never use anything but sequential decision and repetition processing. Never. That's all there is. You only get 3 kinds of Legos, but you get lots of them and you can do whatever you want with them. Let's get you practicing. Oh, good timing. This is a homework assignment. If you have your browser up, go to code.org. And you're not going to have enough time to do it here. If you want to hang out, you can. Code.org is a site that was created by a company, now a nonprofit called Code.org, but programmers because they were trying to get kids interested in programming. Skyward once asked me, he said, I need lots more programmers. How can we get more programmers? Well, first I got to get you in here, and then I got to tell you, you really like it, don't give up, even if you don't like it. No, you have to like, if you don't like this stuff, imagine doing it 40 hours a week, 50 hours a year, or 50 weeks a year at least. Don't do that. Don't care how much money is in it. It does grow on you. I struggled through college, and it grew on me as I went. So don't give up on me too early. It does grow on you. If you like puzzles, man, are you in the right place? Programming is one big puzzle. I'll tell that stupid computer to do exactly what I want it to do. Code.org was developed, billions of lines of code, to get young kids interested by playing games and learning these 3 structures. They don't know they're doing it, but sequential processing, decision processing, repetition processing. And if they do it for 1 hour of code, maybe it will get them interested. Personally, I'm not so sure. How many of you have kids that are 13, 14 years old? A few. You think your kid's interested in writing business programs? They'll go to the elementary school and some old guy with gray hair comes in and says, man, I got a good deal for you. You want to write programs for business that manipulate data and calculate statistics. And they're like, well, how many 12, 13-year-olds want to be accountants? That sounds like an interesting career. No offense to my buddy Bob, the accountant instructor, but not to a 12 or 13-year-old. Most of them are maybe getting out of the fireman and nurse stage and moving into game programmer or financial analyst on Wall Street or movie star or rock star or those kinds of things. But business programmer? So it's tough. And that's what this is supposed to help. When you get here, you're going to do this at home, code.org. It's in my notes. Click Start. You go back to, because for some reason they start you in the middle, probably because they want you to see Mr. Zuckerberg here. That's Mr. Facebook. Go back to, and there's Lightbot. This is the one they want you to use to learn the basics of programming. What I want you to do, if you want to, maybe start now. You have about 5 minutes. I'll hang out for 5 minutes. After that, I've been here too long. All right. Go home. Before Monday, I want you to finish this. It's 20 stages or something. It's built just like a video game. They show you the rules on the screen. You got to figure out problems. Might not be a bad idea if you scroll down a little bit to log in so that you can come back to where you were. Create a user account. And then they have lots more games. I want you to start with this one for Monday and solve every one of the problems. If you can. There's one there that I've had people get stumped on. Try to solve every one of the phases. It's worth 2 ticket points to me. Okay. Everybody know how to take a screen snapshot? On a Windows machine, it's a little tougher on Mac. On a Windows machine, there's a print screen button. If you hit that, it takes a snapshot of what's on your screen, puts it in the clipboard, and you can paste it in a Word document. Try it when you get home. It doesn't work too well here. In Windows 7 and 8, there's also a snippet tool, I think, in the toolbox. And you can take a little snippet of the piece. when you get to the end and you've graduated or whatever it shows you, just take a screen snapshot so you can show it to me, prove to me you made it to the end. Don't let your 12-year-old help you. This is you now. This is you starting that experience thing that it takes to get through this program. It's a little more fun than what we're going to do later. There's no typing. You're going to be doing a lot of typing. Right? It's a little more fun, but the concepts are there. So I'll start if you want. Just, you know what? You do it. Well, you can do it. It's a game. I hate games, but it's a learning game. It's good for you. And once you're done, those of you the teens, give them a shot at it. I tried it on my 7-year-old granddaughter. It was about 5 spaces in. They got more than she could handle. I could see it wasn't sinking in. But we've done this for junior high students, and they crank through these things. Should take maybe half hour or so. I've been yakking at you now for 5 hours. That means you owe me 10, right? Outside class? I'm only asking for a half here. So give it a shot. Do the best you can. If you have trouble, I'm available tomorrow, the day after. Email me saying, and if you're stuck on one, maybe I'll give you a hint. But when we get to the real programming in class, I will. I'll give you hints. Just think about this and you go, oh, that's the key. And off you go. Okay, I'll shut up.
So you just email it to you when we're done?
Once you've got the certificate, yes, you may email it to me. By the way, when you click this, in case you don't know where you are, you're on the web. This does work on the others, iPads, phones. And you don't have to just do it once. This is one of those kind of games you can do it over. I thought I was going to shut up. Okay, I'm sorry. Click. Notice there are 3 different procedures, different ones. You got to click on these to play. Do them in order, trust me.
Boom!
Yeah, there's one. Done. That's another. A couple of years ago, Shirley Wallerman retired. She used to do the dance of joy. I don't do the dance of joy. I might do boom, that's not bad. But what I do is usually about damn time. What took me so long? I want to solve that problem.
Oh, you gotta jump.
What's going on?
You gotta jump.
You're doing the jumping down? Ricky.
If you're using a virtual machine, don't forget you need to log out. When you're done with your Mac, the Apple, log out. This guy up here.
No.